Hi, this is Alex from devstories.eu. NumPy, episode 5 of 7. What happens when you try to multiply a three-dimensional matrix of 1,000,000 pixels by a single small array of three numbers? In many strict languages, you get a shape mismatch error. In NumPy, it just works. This behavior is called broadcasting. Broadcasting describes how NumPy treats arrays with different shapes during arithmetic operations. It takes the smaller array and, conceptually, stretches it across the larger one so their shapes align perfectly. Listeners often mistakenly believe this stretching physically copies data to build a new, matching array in memory. It does not. NumPy handles this alignment implicitly at the C level. It iterates over the same elements multiple times using zero memory overhead, which makes broadcasting incredibly fast and highly efficient. To use it, you must understand how NumPy decides if two arrays are compatible. It does not look at the total number of elements, it looks at the shape tuples. NumPy lines up the shapes of the two arrays and compares them starting from the trailing dimensions, the ones at the far right, and works its way left. Two dimensions are compatible if they meet one of two strict conditions. They must be exactly equal, or one of them must be the number 1. If neither condition is met at any point during the comparison, NumPy throws a value error and the operation fails. Let us apply this to a concrete scenario. You are working with an RGB image. You load it into a NumPy array with a shape of 256 by 256 by 3. The 3 represents the red, green, and blue color channels at the end of the shape. Now you need to color correct this image by scaling each color channel differently. You define a one-dimensional array containing 3 color correction rates. The shape of this array is just 3. When you multiply the massive image array by the tiny weights array, NumPy applies the right to left rule. It places the image shape, 256 by 256 by 3, above the weights shape, which is just 3. Starting on the far right, the trailing dimensions are compared. Both are 3. Because they are equal, they are compatible. Then NumPy moves to the left. The image array has a dimension of 256, but the weights array has run out of dimensions entirely. This is where the second part of the rule kicks in. When an array has fewer dimensions than the other, NumPy implicitly prefends ones to its shape until they match in length. The weights array shape is treated as 1 by 1 by 3. Now the comparison continues. The image has a dimension of 256, and the weights array now has a dimension of 1. Because one of them is a 1, they are compatible. The weights array is conceptually stretched down the 256 rows. This happens again for the next dimension. The shapes align, and NumPy applies your 3 color weights across 65,000 pixels seamlessly. This is the part that matters. The rule only works right to left. If you have a two-dimensional array shaped 5 by 4 and you try to add an array of shape 5, you might think it would stretch across the columns. It will not. Starting from the right, NumPy compares 4 and 5. They are not equal, and neither is 1. The operation instantly fails. To make it work, you would have to reshape the second array to 5 by 1 first. Broadcasting lets you write clean, loop-free code that executes at compiled speeds. The golden rule is always trailing dimensions first. They must match exactly, or one of them must be a 1. Thanks for tuning in. Until next time.